Hi, today I will talk about hearing through bone conduction mechanism. So, this kind of hearing is possible because of the human head anatomy, which is composed of the skull bones, cartilages, etc. So, if we see how is the speed of sound in air, it is much slower. But when the sound enters and is absorbed by the human head, it is because of the various brain tissues, structures, brain matter, etc., that the speed of sound becomes 4 times faster. Now, this theory of hearing via bone conduction was most recently explained by Tondorf, in which he explained two basic phenomena, that is, sound getting transmitted via the middle ear ossicles, and second, that is, sound getting transmitted via the skull vibrations. So, how through middle ear ossicles, that is, these vibrations moving from skull to middle ear ossicles and to the outer ear bony part and getting radiated back into the air conduction pathway, that is via the tympanic membrane to middle ear ossicles and again to the cochlea. And the second mode, which is via the skull vibrations, that is the skull vibrating, the temporal bone vibrating, and directly the vibration getting passed to the cochlea. So, two basic modes of vibrations have been explained for bone conduction hearing to happen, that is the inertial mode, and the second, which is the compressional mode of sound transmission. So, in the inertial mode, which is basically for the low frequency sounds, the skull is in a stationary state or in the inertia of resting position. So, it itself resists any kind of change. So, whenever there is outside acting force, it would indeed move in the direction of the acting force in a unidirectional manner. So, skull would vibrate as a unit altogether, and it can affect directly the cochlea, or it can also affect the middle ear ossicles to transmit the sound via the cochlea to the nerve pathway. The second mode of vibration or bone conduction, which leads to hearing, is the compressional mode, in which the skull is said to vibrate in parts and also in opposite directions. So, this kind of vibration happens for the high frequency sounds basically, and in this, it can either be the compression happening or the expansion happening of the cochlear shell, and this basically happens because of the difference in polarities of the sound wave. That is, it can have a positive or a negative polarity, therefore leading to formation of a rarefaction or a condensation sound wave form within the cochlea. So, it is basically the one point which gets highlighted in both of these modes of vibration of the bones, skull of the skull, and leading to sound transmission or hearing happening, is the one fact is very clear, that the cochlear fluids are incompressible in nature. This fact is highlighted in both these modes of sound transmission, and because cochlear fluids are incompressible in nature, so whatever sound will reach the cochlear fluids leading to its movement will indeed make the basilar membrane to vibrate, and would indeed lead to activization of the inner hair cell and outer hair cells, and further sound transmission happening through the neural pathway into the higher auditory nerve pathway.